New York City is currently investing billions of dollars to address our long-standing combined sewer overflow issues, that is CSO issues, with the goal of making progress towards the 1972 Clean Water Act's goal of fishable, swimmable by July 1st, 1983. We're not quite there. Some of our sewers have served us since the mid-1800s, over 160 years. So one of the key project decisions is to choose a design life. London, for their massive Thames River CSO project, used a design life of 120 years, which would yield an end-of-project performance date of 21/4/40, assuming construction was completed this year. A second decision that has to be made when screening alternatives is what to use as a baseline year. For the Flushing Bay CSO Long-Term Control Plan project, New York City DEP chose 2008 as the year and applied that year's precipitation, tides, etc. in their projections. But a complicating factor is the reality of climate change. Increased precipitation and increased sea level are expected in the coming decades. Our precipitation records for Central Park go back to 1869, and as can be seen, the 53.6 inches that fell in 2008 makes it an above average year when looked on at a probability basis. But going back to the temporal plot, one notices that the past 50 years or so seem to have more variability and seem higher than those of the previous century. If we break the hydrograph into 50 or so year intervals, we can then develop probability plots for each period. First, the period 1869 to 1919, then 1920 to 1969, and then 1970 to 2019. It can then be noted that the first two intervals are very similar, whereas the 50-year interval is significantly elevated, as can be seen on the probability plot. It can be noted that the 2008 baseline flow has been exceeded 37% of the time in the last 50 years. In fact, the median annual precipitation for the first two intervals are 42 inches and 41 inches respectively, whereas the last 50 years had a median annual precipitation of 48 inches. That's over a 6-inch difference, which is significant. Using New York State ERDA data, a 50th percentile and a 75th percentile New York City precipitation projection for the year 2100, that is only 80 years from now, was extrapolated to 2140 and calculated the predicted probabilities towards the end of the project life. It can be seen that the time exceeded would extend from 37% of the time in 2020 to anywhere from 54 to 82% of the time for 2140. We think that most residents would think that this increase is significant and should be addressed, and its implications on expected life cycle performance transparently communicated. Given the reality of climate change, the question posed is, should New York City use an historical year, 2008, for baseline, or should recognition be given to the reality of climate change and the 2008 baseline should be scaled and then used to demonstrate anticipated increasing precipitation? If you design and install a 20-foot pipe and then realize it should have been 24 feet in diameter because we're experiencing greater rainfall, then one might say we've not optimally invested our public funds for maximum benefit. Or, Houston, we have a problem. Our review of the New York City DEP CSO long-term control plan modeling approach identified 5 other issues. The second issue that we found problematic was that the pathogenic kinetics assignments were not specified on either a site-specific basis nor a pathogen-specific basis. As can be seen by this table, there is not a one-size-fits-all disappearance rate. Also, review on Lombardo's or Landtrip's work indicate that not all indicators decay at the same rates. For example, Lombardo indicated that the median decay rate for fecal coliform was 1.1 per day, while fecal strep was only about 0.17 per day, over a factor of 6 difference. Also note that Salakvakmar et al. Also find that not all die-off rates were the same, and it is also important to note that the 20-degree centigrade rates they measured were much less than those base rates of 0.8 per day assigned by AECOM. The third issue identified is that the impact of solar radiation was not included in the model. Solar radiation loss has consistently been included in engineering models since at least the 1970s. Given the reality of climate change and its associated impacts on water clarity, etc., we believe it should have been included, as does Dr. Stephen Chapra, who conducted a review for NYCDEP. The fourth issue identified was that total suspended solids were neither measured or included as a state variable in the model, but settling was determined by the analyst to be the major loss mechanism. Not only should TSS have been measured and modeled, but we also agree with Dr. Chapra that potential importance of resuspension and sediment load should be evaluated. Given that the overall loss rate are greater than 1 per day, and that the concentration and wastewater flow vary hour to hour, and onset and termination of precipitation events is random, pathogen loads and concentrations should be input into the model hourly, not as a steady state constant. As can be seen from this 1978 Newtown Creek graph, concentrations of total coliform varied by a factor of 10 to 20 times on a minimum to maximum basis for this New York City treatment plant. Likewise, Kim et al. Found significant minimum to maximum variations for both concentration and loads. The last, that is the sixth model issue identified, is that the data collection effort had some important gaps. For example, there was apparently no measurement of Secchi depth or light extinction in the program. Also, a review of the analytical summary table indicates that necessary components of forcing functions were not measured. That is, fecal coliform and enterococci for both sanitary and stormwater discharges were not measured. As discussed, the total suspended solids were not measured at all, which has implications in terms of model calibration. Also, we recommend that both temperature, conductivity, and salinity be measured in the sanitary and stormwater discharges in the future. As a postscript, we also maintain that assessment should be made using US EPA sound science water quality criteria. That is, enterococci, max STV criteria. New York State is the only state in the U.S. that has not fully implemented EPA's enterococci criteria, but one would think it'd be reasonable to expect they will implement them during the design life of these projects. Also, please note what Boston has accomplished for their CSO issue via a system-wide approach and an outfall extending out of the harbor. London is also currently implementing a deep tunnel approach, and both these strategies should be evaluated within a value engineering context. Thank you for your time.